Alright guys, welcome. Oh, sorry, I had to stretch there for a sec. Algebra 2a, families of functions. This is the fun part where we're going to use Desmos quite a bit. Families of functions will work off of a parent function, and then you have to tell the relationship between how the graph will look and then what it does to the information. Okay, so right now we're going to go straight up to Desmos. And where is it? Okay. There it is. Okay. Alright, and this is families of functions. These are all the functions you'll see. So the first off one is absolute value function. Okay, so the absolute value function is going to start at the origin, and it's going to have a slope of 1 and -1 going up in both directions. Now the reason why it doesn't go down beyond this point, down to here, is because it is an absolute value. Okay, so it's hugely important to understand that we are not going to be messing around with absolute values too much. Well, I mean, we're not going to be messing around with negatives with absolute values, because everything that is an absolute value is always going to turn positive because it's distance from 0. Quadratics, the same thing, except quadratics are going to be positive because you're always squaring something, and whether you go positive times a positive or negative times a negative, you still get a positive. Okay, they're going to have the same thing, and this is what the parent function looks like. It starts at the origin and it's a parabola going up. Okay, cubic function is going to look like this. I call it the snake, except cubic is going to have a negative portion because if you cube a negative number, you'll get a negative answer. So it's very interesting on how to work with that. Okay, there's also rational functions, but we'll talk more about that in semester 2. Square root functions you'll see this year, which is just basically the inverse of a parabola type thing. Okay, and the cube of the cube root function, which is the inverse of cubing. Okay, exponential functions we won't focus on right now. Alright, so now, if you notice, they all had letters in front and a. It was timesing them. Okay, so what that means is that a times in the front is going to influence my answer. So if I put a 2 in front, it's going to influence my answer and appear to make the graph stretch up. But what in fact it's doing is I'm doubling my answer each time. So if I put a 3 in front, I'm tripling my answer. If I put a 4, I'm quadrupling. Now if I decide to go less than 1, it's going to shrink my answer until it gets closer to the 0. Until it gets closer to the x-axis. And as you can see, it gets pretty close. Okay, now if I make it negative, it influences it by making all the values negative. So I know I said up here in the absolute value that it's always going to be positive, but this stuff is going to be positive. This is going to change the sign after you get done doing the operation, so that's interesting. Okay, and as you can see, it has the same effect on all families of functions. Okay, all the ones we just talked about. So I'll change this back to 1 so we can focus a little bit less on it. Alright. Alright, now B you won't talk about till pre-calculus, but I'll show you in a second what it does because it also works with H. Now H is a number being added inside the function. So it's inside the absolute value here, inside the square here, inside the cube, inside the square root, inside the cube root. Okay? Alright, so H is going to influence it. Now here's the weird thing, is H is going to influence my answer by either increasing or decreasing, but before I do the operation to it. So it's really going to be interesting to see how that works. Okay, now if you guys have been paying attention in your other classes, you probably already talked about this with parabolas, but it moves it to the left when I make H positive. Now that's an illusion. Okay, what's happening is this normal point that should be at 0 for all these graphs, when I increase the H, let me go back to this, when I increase the H, it now goes up to 1 because it's now increased by 1. So it's no longer here, but it's here. So I've added 1 to it. But it gives the whole illusion that my graphs are moving to the left. And if I put a 2, it's going to increase it to 2 and just keep moving it up and up and up. Obviously not on the cube root because the cube root is just its own funky little thing. Okay. All right, but as you can see, it moves it up and just keeps doing that. Okay, now if I make it negative, it looks like it's going to the right. It is an illusion again because I'm actually decreasing all the values. Now the reason why the parabola and the absolute value both appear not to be going negative is because once again it's the whole function idea that square absolute values do not give negative answers. Okay, so let's move back to the middle. Alright, now k, if you look at its purpose in each equation, is it's being added after the function has been worked with. Okay, so it's being added. So in other words, it's increasing the values of the y's, the answers. It's increasing the value of the ranges. Okay, so if I make it bigger, then all the answers will become bigger. If I make it smaller or subtraction, then everything becomes negative. Okay, now for some absolute values, just so you know, that's the only way you can get negative answers is by subtracting from the final product. But just remember, if you notice, if you look at all the equations, there's a plus k. I can do a whole bunch of stuff with it, but it's being done after the function is done. Okay? Alright, so that is pretty much it for families of functions. You can tell definitely what something's being done. Like I've noticed that some questions are being asked if g of x is a function, then what is happening to 1/4 times g of x plus 5. And so what you can do is you can notice, oh, this is in the same spot as a, as in my family of functions, and this is in the same spot as k in the family of functions. So that means that this one is being compressed I guess horizontally, no, vertically, because it's being pushed down. Okay, and then this one will move the graph up 5. So I can tell, I don't even know what function this is, but I can tell because there's a number in front being multiplied and a number in the back being added that it's going to get really kind of funky. Now if I had to compare g of x with this, g of x minus 3, I know that from my experience that that's a lot like the h. Okay, so that means that this graph is actually, it's going to be given the illusion of moving to the right. Okay, because I'm decreasing each value, thus making it look like it's moving to the right. So, you know, you can just tell by looking at what's being done to the function of what the graph, the resulting graph is going to look like, or what's going to happen with the answers. Okay, that's pretty much it for families of functions. Go to Desmos, check out the sliders, and have fun with it because it's a lot of fun. Okay, talk to you guys later. Bye.